Welcome back to Wickerson Studios. We are on to the third Grasshopper script, which is available at NumPy into Grasshopper or NumPy assets, array, and vectorized computation into Grasshopper. And we have gone through in this section the indexing and slicing of 1, 2, and 3D array functions and built a little bit of a geometry here to look at, but it's not much to look at. So that's a pretty simple visualization of just looking at tree information and being able to slice through it. So I can slice through my first part, I can slice through the first section and kind of bring it up to 3, 2, or 1. It's not the most exciting one to build geometry, but you can see how it changes. I can go to the second section, go to the last section, and I can go to, I believe, the third section. So you're kind of like thinking of this as a box array to build geometries. And then I did a little bit of Grasshopper geometries because, as you know, I'm only using Visual Studio Code to process NumPy, which is numerical based, and then I'm pulling that into some simple geometries and grids that I can build triangles out of, group curves, and then do a little rotation through, and then just simple off through those points. So the geometries are very simple to follow, but they're using a parametric index and slicing of a 3D array. And we'll take a look at that. So we're just going to pull this down to the side. We're going to start with our major script. Indexing is what I wrote, and you'll see I added 1,000 lines code to this with the help of GitHub Copilot, and it's not too hard. So the first indexing comes in. I've got it hard-coded in initially, so anything that's happening, you can see that it's actually stepping through at 001. You'll see that it's actually being hard-coded in at the array of start at 0, then 2, 5 with a step of 2. But what I tried to do was then show you how you can make that parametric in the very next version. So if we jump over to here to NumPy indexing 4, now the numbers at the end are only in troubleshooting and problem solving things, because you have to change the names every time you have an issue, or else this thing will keep trying to cache all your items, and your nodes will try and cache all their items. So you have to take those off. But anyhow, you make something parametric. So now I can slide through that list from a start to finish, and I can use the steps as to how many numbers I want. And that's basically it. So that's going to continue through a broadcasting assignment. And yeah, I'm going to do that hard-coded and then parametric, and then I'll do some slicing of an n-dimensional array. This is slicing 03, and the numbers once again are just plugging through, trying to get it hard-coded in, and then showing how you can slam in all those numbers to whatever you want within slicing this. So if I went from 2 to 9 and I wanted to step by 1, you get the effects of all those numbers. Actually, I don't think the step matters because there is no step in this one, so that's obsolete. But you can replace those numbers with whatever you want within those steps if you want to affect this data. The whole point of this is to do some data manipulation and mudging, and using Grasshopper to do that, to visualize it outside of Python or Jupyter Notebooks or things like that. And then explicitly copying an array is something I hard code in here. And then I go over here to do the same here to copy an array. And that would be the slicing 06. So as you scroll down, you see here it is hard copied in, and then you'd see it. So it's actually parametric. Parametric here and before hard copied in. I don't think there's much of a difference. Start, stop, and V as an input. Let me just see what that one is. There's the 5. The next one should be 6. Should be right here. There it is. So there's your definition where you put your start, stop, and your copy in, and the value you can change down here as well. So pretty simple stuff to start. And then what did we kick into? After that, we're going to go to 2D arrays up here. And I wanted to show how we could start to use, in this one, it's fairly simple because I'm actually going right away to use the tree structure with the entwine tool, so we're not stuck just outputting lists. The biggest thing I tried to do is keep all 4 loops out of my script. So 2,500 lines of script in Python without using 4 loops is pretty good, because you want the power of vectorizing and going through everything at once, all the data all at once to change it. Excuse me. So that's enough to start slicing a 2D array. Down here, I got rid of this data. I didn't need that one. And then recursively slicing, you go into either the path and then you choose the index in that path. So if we choose the last one and we go to the last index, we're going to get 100, and that's where it's going to jump to. And that is running fairly quickly at indexing 5, and there you go. Then we're going to get into what's the problem with multidimensional arrays. And here's where it gets interesting, I think. Oh, not quite. We'll jump up here and we'll show that we can actually index and have that happen again with a 3D array. So with 3D arrays, we're bringing in 4 lists, and we're actually bringing the data in. You'll see here under the array 3 that that's a 3D array. It's not just a list of lists. It's a list of list of lists. And at that point, we can kind of grab hold and index and grab the elements of what we want to do. And I am using the array to list function and then putting the array out. The next one for 3D array is this one here. And what have I done different? I've introduced let me just think about it. Oh, a start, a stop. No, the index to the first index, the second index, and the element at the end of it. So I can actually sit in there and choose whichever index I want. And you have to choose 0 or 1 on the rows, 0 or 1 on the columns, because that's how you have to think of an array. And if you want to see what's happening, I think down here, you'd get the visuals of it, but I've got a lot of data processing here. So it's hard to find it within that terminal. Got a pretty big script here in the Grasshopper script, but easy enough to start. And then what I do is I started hard coding and indexing a 3D array, exactly what I did before, jumping in and seeing which ones I wanted. But this one, it's not, it's been hard coded as in the 1. So as we go through here and slice through this one, you see that I hard coded 222, so it's always going to stay to that box, that smaller box that's in here. And then I really did something a little more parametric here, where I introduced the index 3. That this is the one I took to the geometries. So this one I can actually close this off down to a 0, 0 array, and I can bring that down to all 3, to just the box of 2, to just the box of 1. And of course, you still have to step through in the box of 2 to see which box you want, which are these boxes up here, if you think of those visually as arrays. So what I can do is I can produce these pretty interesting geometries, which is what I had here. And that geometry was being driven by this simple geometry that I started with. Then things start to get interesting. And you have to remember that you have to use this array to list format when dealing with bigger arrays, and we'll jump into that in a second. We'll finish the script, and this is available at wickersonstudios.com. The first one I did, I just jumped right in, and because it was a list, you can just use lists. If it's a 1D array, you can just treat it as list. There's lots of samples down here to run, but if you want to wrap them into components, you're going to want to go here, and let's just double click here. Let's grab that. I shouldn't neglect to do this. Copy, close, right click, and name it, so you know what the call is on that function. If it's not working when you come in, you just have to grab this, a new node. You have to go here, you have to grab this call function, hit OK, and then right click here, left click here, and drop it in here, and you'll be able to run that same node. So you have to make a new one if it's gotten kind of jittery. So running through here, you can see it's pretty much like a series function, range function. We just want to snip out, we just want to slice between that open list. A very simple tool, and you can see it's generating down here. And I've removed that that list item that I was using before, and I thought it was so simple, why even leave it in? But I'll just leave it there for the older way to do it, but the way you want to do it is the array to list. And then we go into indexing and slicing a 2-dimensional array, and let's fix this up a little bit. Let's grab that ND array slice 4, copy, OK, right click, and put the name in here. Why not? Make sure it's matching here. And also, if you brought in a new array, you'll want to take your cache off if you want to see how it functions. Okay, so now we're able to step through this array all the way to the item, and then we could also grab the list item that we want. And that's with the 2D array. And you can see it's been input here under under 4. You see it's been brought in list, list, list. So it's actually a 2D array, a list of lists, instead of a list of lists. And that one will run the same. I've kept it with a list component coming out, and I've had to use this for a 2D array selection. And this is an anomaly of how I was solving that, because what happens when you get down here is you have to start using that for list to output the list. You just have to do this when you get into 3D arrays. Sorry, this is the list getting in. It's another way to do it. If you want to use the list to step through it, which is what I did with the 6th example. And the 6th example is over here, and I believe it's down here. This is the first one that's using the list, but we want to try solving that. So here's the example of using list to start. You've got the start and the stop of where you want to go in each group. And so as long as you have this 0, 1, 2, 3, you can grab there, and the 0, 1, 2, 3 here. So you can kind of grab that data from where you want, which section you want, and how you want to call that out. But it is using the for loop. So if we go to the next one, you'll see that I've removed that, and it's the same thing running over here. So these are the functions that are working very well. Group, and I'm just going to put that to box outline. No, put that to rectangle outline. These were the ones that were using lists, and this is the ones that were using the proper array form to list, if you want to think of it that way. So jumping in here, you've got some good sliders. You have some good parametric control for slicing a 2D array, and you can see the 2D array is a list of lists. And I've just left that as the older version, which was being used up here. But I've called that out, and I've just commented that out as well. Then we go on to using step sizes. So going back in and just dropping in a step size to find these. And if they're not running like this, what you will have to do is this should be running fine. This is an example of getting it running again. It's just not, it's not processing. So I'm going to stop here. Not sure why it's not working. Let me copy. This is 8. This should be running fine. Okay. Let's click here, said okay. And with any luck, we should be able to get this up and running again. Little problem, little glitch with hops that I find. And hopefully we've got our data coming through in the end. And there it is. So that's the only thing you'll have to do. And then this data, you just want to grab the name, copy. And sometimes it's running from what I have, and sometimes it's not. That's just the nature of it. There you go. And you've got 8. So that's with the list item. And then over here, I solve it. And actually, you also see I moved from this type of listing to using multi-dimensional slide. Sorry, using one of those things called gene pools again. Yeah, gene pools, which are a nice multi, list of parameters, a list of numbers. So that one's running through, and that's the 8.8c, which will show you how to write it within the start, step, stop to list. So that's a nice fast way to do it. And now you can jump in here and you can grab, still dealing with the 2D array, just a single list, but how to get that one up and running. So that's it, start, step, stop. So I guess I returned a 1D array, 2D array, and 3D arrays. Now the same thing here, I'm going to show an example of using it with list. And the title should be there. Oh boy, fixing all this up for the package. I'll have to update the Wickerson Studios plugin just to get this up to speed. And we'll just put this on here. And there we go. And that one's up and running, and you've got a start and a step and a stop, which is kind of nice in all directions. But you'll see here, it kind of, you don't really need this. I think you can hard code in that, which is what I did in the end. As I started to work with this one, 10D, right here, you'll see that I hard coded in 0, 3, 1, and then I have the start, step, stop for the end, because that's really all you need to do if you want to come at it from the end of each item. If you want to come at it from counting up, slicing up to 2. So this is a really nice script. I'm going to turn this into a geometry, and then you can step through it to change the data. So I'm going to drive geometry with this node afterwards. Down here is a data visualization. So let's just remember to do that, and I'll have that on the latest version. Let's bring that over here, and we'll do a little data visualization for this one to start. And we may do it for this one, the 3D slicing as well, which is nice. So as we continue with, I think it's 19 sample. There it is, array ND19. You see how many tries it took to figure this thing out, or to figure it out the way I liked. Every subtle change, if you don't want to get into trouble, just rename your script while you're changing it. So that one's up and running. And then this one's the same thing. We're going to have it hard-coded with list, working with list, and then we're going to have it run right here. And you can see the really nice way of setting it up, that you've got the box array that you can grab the whichever one you want. Now, this is simple because you're indexing and slicing the step. I'm not actually slicing on this one, I'm just indexing, and it's hard-coded in that I can grab and output each one separately, which is allowing me to do 3D array operations within Visual Studio Code, not within Grasshopper, and then output that data. So it's really not doing anything over here parametrically, but it is running it nice and smooth and do a nice little script right here. So I'm very happy with this script. And then where would we go from that? We're going to jump up here to 20, and this is where things start to get more parametric with that. Now you can go through and you can index and slice with the same thing, and this is 20b. So things just get slowly stepping in to become a little more complicated. And here I've got this notation of 0 to 1, and I thought that would be necessary for me to step through from here, the beginnings to the end. Let me just figure this out. If I go step 1, and I don't want to take it up so high. Now what is going on with my script here? It should be fine, but I'm a little curious. This should be running. That one should be running fine. Why is that one giving me trouble? I might have to take a little break for a second. So this one should be, This is the stepping through those, and I should be able to do a start, step, stop at where I want to start in each one. And I wanted to start, just curious what's going on with that one, so give me 1 second. Step size is out of bounds. Oh, because I have to step through this one, this one, this one. That's kind of tricky. I might have to hit pause or come back to that one and see which ones I've gotten wrong. One is out of bounds. Why is that one not running? And that's interesting to me. I'm tempted to just try another one. And let's just see if this makes a quick fix. I'm not sure if it will. Copy, okay. I had it working. And now I'm wondering why it's not working. Whoa. Let's change that one again. Okay. Maybe I'm just going to hit cancel here. Refresh this one, run it again, and that one should be fine to copy. Okay, this one should be good to paste, and there it is. Now let me get rid of this one. That is strange. It might be the order of putting in the lists, or maybe I changed something. Maybe I really made a mistake here. So we have the start. We're going to do the stop to 3 as the end, and then this is the count. That is there. Okay, there, there, there. If I did a count by 2, why isn't that changing? It is defaulting out. Well, I have to check that script again, which I thought was working fine, 20b. Anyway, we'll go on to 20f, which has the same type of writing. Maybe that one was faulted because I hadn't got around. Let me check what that is. That's a list of lists. Maybe that one just doesn't work. And I fixed it down here under this one, which is the, aha. I think I see what's happened here. Now this is 20F, which is strange. This one should be running fine. This is grabbing a kind of hard-coded element. So the element I want to grab in each one. So I'm grabbing a single element in each one. And I noticed a little trouble here that this should not be written B. So it's good I'm going over this, just fine-tuning this in the tutorial. But it shows you how to fix things up. And whenever you're renaming things, it can be an issue. So let me grab this one. I think I've got the problem here. I think I just didn't delete something. So we'll check it out. And let's post that there. That one's running as an integer. Now this is the one that I'll want to step through and have this move. I think that's what I'm doing, is I'm getting gradually more complicated as I go. This is running okay with the element hard-coded in here, and then I wrote it down here with a start and an end. Okay, so now I can grab what I wanted to do, the start and the end, exactly. Okay, and then what I added was the start and end to 20H, which allowed me to get in here and I guess write the same one again. I thought I had elements on it. Maybe I just didn't save the script. No, that's it. That's the start and end, starting and stopping without a step. So I could have added a step and I didn't do that. So start, end, and I guess all I have to do is add the step, which means that this initial one up here doesn't even exist that I had going here. There's the 20B, and that was the problem. I probably named something wrong. This one up here, 20B, is the one that's running, okay, initially. So this one was running as a faulting out. So yes, this one was not running as is. I could only just step through and show all the data. It actually doesn't change with anything. The start end isn't. Start end step was not functioning. So this one has some functionality, but it's not what I want. It's just allowing me to hard code it in as 0, 3, 1, which is where I learned that's what I have to hard code in. So it wasn't running here, and it was working, but it doesn't change. So this is not the way you want to script. And I think what I'll do is just possibly give a warning for that one and take it off a start step stop, because the start step stop, I ended up not putting it in. I didn't make it parametric through, and you can't change this because you basically have to output each one. So there was a problem with that. That's why I moved from here. So maybe I'll just put a cautionary yellow on there, group, and then a cautionary yellow color, which will remind me that there's a bug with that. There we go. You just can't do everything you want to do with that one. And then the only thing I wish I pushed, which I didn't, was I didn't put my step in there. But it's getting pretty thick with 3D arrays, so I'm okay with just having this one be kind of bugged out. And I should make a note of that. I think what I'll do is I'll take that one off. Yeah, I think I'll take that one off because it doesn't really function. So yeah, we'll just leave that yellow and leave that one off. And then you slowly solve through to the end before the Booleans. But even here, you don't have the start, step, stop, which is what I was trying here. So I went in and I got it working at least with the index, with the element at the end. Then I had it working with the step. And you could add your, and then you probably just want to add a step to this one. So the difference between this one and this one, which is G20 and GH, is G20. I hard coded this in, okay, and GH, I simplified it. I realized this was obsolete. This hard code was already given, so I didn't have to put it in. So I simplified the entire version of this without the step, which is okay because I will want to grab data out of here. And even though I might want to step through it differently, I think what I want to show is that you can use 3D arrays and you can actually grab data from the start to the end or the end to the start. You can downsize the size of what you want as well. And that is the start and end. So that's it. Nice little end. Grab it in the middle, grab the middle numbers, and grab the beginning numbers of each of the array boxes. Thinking of it, and also you can process that data over here. So I should extend this. I'm just going to make a little note. Use a step size in a 3D array. So it already knows I want to do that. So I'm just going to leave that until after, and there's the hops component writing itself. So I'll just add one in there. And I'll do that before the next version, and then I'll do some data visualization with that final step version right here. Okay, so I have to do that. Slicing step. Okay. And then we get into Boolean indexing, which is a totally different animal. I should have probably started my next script, my G004. And with that, you can see that it can read data like Bob, Joe, Will, Bob. And then the logic in here is saying if, you know, Bob, the names equal Bob, then you can pass on this data of the list. So it only passes on the first and the second. And of course, in doing so, I don't think I did it with dividing it. So I wrote that from list form over into array form and then listed it out as array with the entwine node, because that's how you have to step around to use the data to maintain the data structure. So I've done that enough times. Fancy indexing is a nice little thing. Fancy indexing jumps in here it talks a little bit about some really cool attributes of masking and conditions, and it had this one little operator here that was interesting. You've got the operators of the and or, and what happens with that is I step through and process it here into fancy indexing, which basically produces 0 rows, and then it initializes all those 0 rows to stepping through a range. And even though there's a for loop there, it's okay. That's just the process of trying to put it in, and then I change, and then I have all the outputs to the list, the 3 list. So you started with a random, you started with the zeros column, and then you started to put in the data through the range. So that's a nice little fancy indexing tool. And transposing is getting towards thinking about multiplication. So transpose is this: you can take anything and add this t function or method, and all of a sudden everything gets transposed from its original. We can't see its original. I didn't output it, but it is transposed here. And to prove that, in the next version, I multiply the original one by the transposed with this at symbol, and this at symbol then transposes the matrix and multiplies itself to itself for dot product, cross products type stuff. So then you get these multiplications that you're actually doing the correct multiplication, element-wise multiplication, which is going to become more and more essential as we go. And then the final last one was swapping accesses before we're going to get into random number generation. But swapping accesses is the axes is the last thing we're doing, and it simply moves the position. If you were looking at the initial one that you generated, which was this list of numbers, and those numbers are coming in as a list, and actually just as a row and column list. So it's generating, and then I'm flipping the axis from rows to columns, and there's your output. So you can do the same thing with that when you get into it. So back to this one, I will finish it up for the next video. I will correct this with step. We'll introduce that. It shouldn't be hard to just add another variable, and we'll get it running into a nice data visualization. And then when we're done that next video, we're going to go into random number generation and get hard into the AI Copilot to AI Stable Diffusion 004. Thanks very much for watching. Stop recording.